Good afternoon, students. This is me, Dr. Bandari, and I have my TA Srinath here. We are doing some videotaping of this week's lab, which is soil textural analysis. In this video, we'll be particularly focusing on activity 3 from the lab, which is the particle size analysis by using hydrometer method. So that's what we'll be doing on in the lab today. So if you are wondering how how we can do this lab is using the Stokes law, which is derived from force of gravity equals to force of buoyancy and force of friction. So if you kind of look on this picture, you can see force of gravity that is pulling the particles down, and force of buoyancy and force of friction is pulling the particle up. Well, not exactly pulling up, but the force of buoyancy is helping to settle it down or float on the liquid, and force of friction is also helping the same way. So the Stokes law describes the velocity of a particle falling through a fluid. In our case, as a fluid, we'll be using the DI water. So that's what we are trying to do here in our lab today. Here is the equation that how we can calculate the velocity of each individual particles. The velocity of each individual particles is proportional to the square of the particle radius. So we all know that sand, silt, and clay particles, they have different diameter or radius sizes. So because of that differences in diameter or radius, they settle down in liquid on different velocity or different rate. So that's what we are trying to do in this lab, trying to capture that. So you can kind of see that in this picture here. You can have the cylinder like that, and then you can have like sand, silt, and clay, different size of diameter or different radius down there, and from there, if we kind of start here on those tubes, and if you put like sands on one tube, silt on the another one, and clay on the another one, and start the timing. So it's 0 right now, but if you kind of start the timing, then potentially after 40 seconds your sand will settle down all the way to the cylinder. Okay? So it just takes like around 40 seconds for the sand to settle it down, and that will leave only the silt and clay particles or on that mixed up down there. So for the silt particles, it takes another 2 hours to settle it down. So if we measure that after 2 hours, then perhaps all those silt particles will settle down, but still you will see some of those clay particles on that mix up there. So we kind of use the hydrometer that measure the solution density, and we can use that information to determine texture of your soil. So that's what we are doing in our lab today. We'll kind of use the soils that you collected in lab 4. We'll be using 2 soils, one soils from each lab section, and we will be showing you how to determine texture of the soil that you collected, and we'll kind of go through it. So from that standpoint, if you kind of look on, it takes only 40 seconds for the sand to settle it down, around 2 hours for the silt particles to settle down. For the clay particles, it takes hours, 5-6 hours, or even more than that. So that's how it kind of goes on. So after 40 seconds, you're measuring the sand particles down there, and we kind of use that information to calculate the rest of the others. So a little bit on the methodology. We will weigh out 40 grams of oven dry soil, put that on the stirring cup. We'll fill the stirring cup halfway with the DI water. We do have the DI water here, and we will add another 10 milliliter of dispersion solution. That dispersion solution, we mix up the sodium hexametaphosphate and sodium carbonate. Mix that, add the dispersion solution, and then mix the solution for a little bit, stir that, and then let it stand for 10 minutes, and that will initiate the chemical dispersion. And after that, what we'll be doing is we'll place the cup on the mixture and stir that. Basically we are grinding that for 5 minutes. Steps will help to complete the mechanical and chemical dispersion process. So what we are doing here is basically we are trying to disperse all those individual particles, sand, silt, and clay. We are trying to disperse that using mechanical force and also using some chemicals, so that we can measure those particles individually and determine the texture of that, right? So after the setting, after the mixing, then we will transfer all that sample to the sedimentation cylinder. So they have a sedimentation cylinder here, and we'll fill up that cylinder up to like 1,000 milliliter, which is exactly like 1 liter mark. And then we need to agitate that mixture uniformly to suspend all the materials throughout the liquid. This step 6, can be done in 2 different ways. You can use the stopper and embody several times, or you can use the plunger. Today in our lab we'll be using the stopper to do that step, and we will set it in a manner that would not produce circular current. So you kind of do it this way rather than creating a circular current. And then after that, the next step is when we complete that, we'll set the cylinder on the table and we'll remove the stopper and mark the time. So after, you need to be a little bit careful on this one, because after 30 seconds we'll start inserting the hydrometer into the suspension and release that slowly and take the readings of that hydrometer, lower meniscus, exactly in 40 seconds. So we'll do that a few times, at least twice to take the average. Technically, it's recommended to repeat that 6 and 7 times until you get the hydrometer readings within 0.5. And at the same time, after that steps, we will be measuring the temperature as well. We do have the thermometer here. We'll be measuring the temperature using the thermometer for 3 minutes. And you'll use that information to calculate the corrected hydrometer readings. So if you have temperature greater than 80 degrees centigrade, you have to add 0.25 gram per liter to the original hydrometer readings. Same way, if you have lower temperature below 18 degrees centigrade, you will subtract that 0.25 gram per liter from the original hydrometer reading. So that's what we'll be doing on. We'll provide that information to you all, and then once we are done with that, taking the hydrometer reading, taking the temperature, we will let the cylinder sit down for another 90 minutes at least, around 2 hours to 90 minutes, and then we'll come back and take the hydrometer reading again, take the temperature again, and then with that information, you can fill up all this information down here. Your soil weight will be 40 gram. We'll give you that information like average 40-second hydrometer value. So we'll be using that average value down there. And then we'll give you the temperature here. So based on the temperature, the number 5 will be, you'll be using the corrected hydrometer reading. So you'll kind of do some calculation a little bit and then use that information up. And then we'll give you the value again for another second hydrometer reading after 90 minutes. And that will go over there and we'll give you the temperature. And once you have that, then you can calculate the percent of sand, percent of clay, percent of silt, and use the soil texture class, use the textural triangle, and then determine what is your soil texture. So you can use this one once you have all those informations. Once you know the percentage of sand, percentage of silt, and percentage of clay, then you can use the textural triangle to determine your soil texture type.